Alright, so today we are officially starting chapter 12. We don't do very many sections out of chapter 12, just a few of them. But today we are going to solve quadratic equations involving perfect squares. So first, let's just real quick talk about what it means to be a quadratic equation. So quadratic means that x has what exponent? Squared. So quadratic means that we're going to have a variable squared, usually x. And today they are going to involve perfect squares. So what are some of our perfect square numbers? Saw Houston say one. Keon? What? 9 is one of them. What are some of our other ones? Four is one of them. 16. What's the smallest one? 1. Okay, so we have to be able to recognize our perfect square numbers. That'll still be helpful today. So remember 1 times 1, 2 times 2, 3 times 3, 4 times 4. It's going to be very helpful if we can recognize those today. If on your pink factor sheet, if you want to have that out, on the boxes that are perfect square numbers, if you want to like kind of highlight around that box for your perfect square numbers, I would be okay with that. So for example, the box for 16, it should have 1 times 16, 2 times 8, 4 times 4. If you want to kind of highlight that box and any of the other perfect square number boxes on your pink factor sheet, that's fine. It doesn't mean write any words, just kind of make the lines bold or use a highlighter to go around them so that they stand out to you. Okay, let's jump into those warm-ups. So our warm-ups are to simplify. 1, 2, and 3 all involve perfect square numbers, even though 2 of them are not going to be on your factor sheet because they're too big. So when we are taking the square root of 121, one way we could simplify it would be to make a factor tree. Now this one is a little bit tricky. What could we multiply 2 to get 121? 11 times 11 is going to be what works here. Why is it nice that that's what works? Because it's a pair. So that means the square root of 121 is equal to 11. Do we need a radical anymore? No. So we can just leave it alone. What about 81? What do we want to break it into? 9 and 9 is a good option because it's a pair. If you wanted to use 3 and 27, you could, and you'd break it down further, but then you'd end up just multiplying a couple 3's back together. So the square root of 81 is 9. Do we need a radical anymore? No. So that's our answer. On number 3, what's different about that problem? There's a negative out in front, which really just means that our answer is going to be negative. We don't really have to worry about it too much at first. So what can we break 169 into? 13 and 13. 13 times 13 is 169. That's good because it's a pair. So the negative square root of 169 is equal to what? Negative 13. Good. Again, when we've got perfect square numbers under a radical, we don't have a radical as part of the answer anymore. comes out perfectly. 4 and 5 are a bit of a review from what we've talked about in chapters past. If I'm taking negative 5 squared, what does that mean? Not 5 times 5. Negative 5 times negative 5. Because it's in parentheses, both of those 5s are negative. If the negative's not in the parentheses, we don't include it when we write it 2 times. Negative 5 times negative 5 is 25. All right, the other one is just a 5 squared, which means we take what times what? 5 times 5, and we get 25 again. All right, I know this is small on the screen, but you've got it on your page in front of you, so we just have to fill in these blanks. The following properties can be discovered when solving equations of the form x squared is equal to k. If k is positive, then x squared equals k has 2 real number solutions. So what those solutions would be plus and minus k. So x would equal k, or x would equal a negative k. Those would both be solutions. If k is 0, then x squared equals k has 1 real number solution. X would equal 0. It's the only option. If k is, anybody think they know what goes on this blank? Negative, then x squared equals k has no real number solutions. So you'll notice we don't write anything after that because they're not real numbers. You will not deal with that situation until Algebra II. They're called complex numbers or imaginary numbers, and you don't get to that until Algebra II. So for now, if you end up with a negative k in this situation, you would just say no solution. I don't know if we'll see any of that today, but we should be keeping an eye out for it. That might also come up if you try in your calculator to type in square root of a negative number. If you have a scientific calculator or a graphing calculator and you try to type in square root of negative anything, it should say something like domain error or something like that, that it doesn't understand what you want it to do because it's not a real number. And the calculators that we use are not smart enough to deal with complex numbers. Okay. Questions, concerns? Okay. Then let's try doing some problems. So we just kind of jump right into these examples. So we're going to have to think about what we're going to do to solve these. We are given x squared equals something, but we want to get x alone. So what operation is the inverse or opposite operation of squaring? Kind of like how addition and subtraction undo each other. Multiplication and division undo each other. There is an operator that we know that undoes squaring. Radicals, square rooting, good. So squares, the exponent, and square rooting are inverse operations. So if you want to make a note of that, exponents And radicals are inverse operations. So if we are going to try to undo a square, we are going to have to take a square root or use a radical. And if we do that to one side, we have to do it to the other side. Questions about that? Do it to one side, do it to the other. All right, so the square root of x squared comes out to what we wanted it to be. It's just x. And the square root of 64 is 8. But remember on that last box, it's not a box, the last slide that we filled in, it said that if x squared equals a positive number, how many solutions did we get? 2. So we have 8. What do you think the other solution is? Negative 8. So we should include both of them. Sometimes you'll see it written as x equals plus minus 8. Have you seen that plus minus sign before? Okay. You might not have. It's okay if you haven't. But I don't care which way you write it. If you want to write both of them separately, or if you want to write it with a plus minus sign, that's fine. But we should have both of them for now. All right, on example 2. What am I going to do to get x squared alone? Square root. Do it to one side. Do it to the other side. So if I take the square root of 196, what do I get for x? 14. Or we know we should have 2 answers. The other one is negative 14. Now, if you're not sure about the whole 14 deal, I would recommend, first of all, getting a calculator, scientific calculator, if you have not already done so. And if you're not sure about how to use the square root function, where to find that button on your calculator, let me know after notes and I can show it to you. But if that's not an option on your calculator, we can just do what we've been doing for the last couple days, last few days, and break this down using our factor tree. So we would have 2 times, what would that be? Well, you could figure out that it's 14 and 14, which is a pair, or break it all the way down to 2s and 7s. Whichever way you do it. You don't have to have a calculator to do these. It's just going to make it easier. But there would be our answers. Questions before we move on? All right, the next couple are a little bit different. Why? Good, there's a number in front of our variable, so we have to deal with that. So remember, when we are solving equations, we kind of go backwards from our order of operations. So usually exponents would be one of the first things that we deal with, but now it needs to be one of the last things we deal with. So first we need to deal with this 9 out in front. What operation's happening between the 9 and the x squared? Multiplication. How do we undo that? Division. Divide both sides by 9 first. X squared equals 9. 81 divided by 9 would be 9. Are we okay with that first step? I think some people were jumping ahead. Now what are we ready to do? Square root. Now that there's nothing else around what's being squared, we can square root. So x equals 3 or negative 3. All right, on number 4, what do you think we need to do first? Divide by 4. Does 49 divide nicely by 4? No. So I want you to leave it as a fraction. 49/4. Leave it alone. What's nice about both 49 and 4? What kind of numbers are they? Perfect square numbers. 49 and 4 are both perfect square numbers. So my next step to get x alone is to do what to both sides? Square root. So we just put one big radical over that fraction, and we can take the square root of the top and the square root of the bottom. So our answer will still be a fraction. The square root of 49 is 7. The square root of 4 is 2. So if positive 7/2 is an answer, what else is an answer? Negative 7/2. Those are my 2 answers. An expression such as x plus 1 squared, x squared, or 5x minus 3, the whole thing getting squared, is called a quadratic expression because it has what exponent? What exponent? Squared. So because it's got a square on it, that's why they're called quadratic. Even though the squared isn't necessarily just on the x, the whole thing's getting squared on some of these. It's called a quadratic expression. Whenever an equation can be expressed in the form perfect square, whatever that might be, is equal to k, you can solve it like the previous examples. So let's talk about what that means on number 5. They've got a whole expression squared, and it's equal to 100, which is a perfect square number. So, what do you think we need to do to undo the squaring? What symbol should we use? A square root or a radical. We can still do that on these problems. If something is being squared, in this case it's a set of parentheses, to undo squaring, we square root. These are going to be a little bit different. When we square root the left side, what am I left with? If we're undoing the square, what's left? X minus 3. That whole expression is left. Equals what? 10. Or, remember, on these we get 2 different answers. Negative 10. Do you think the x minus 3 part changes? No. So x minus 3 is also equal to negative 10. Questions about that? Keon? Okay, let's talk about it. So we had something that was getting squared. This time it was parentheses instead of just an x. But it had an exponent of 2. To get rid of that exponent, we have to use a radical or a square root. So I had to square root this side to be able to get rid of that exponent. But if I do that to one side, I also have to do it to my other side. When we square root the left side, all it does is get rid of the exponent. So everything else stayed the same. The x minus 3 came down, but now it doesn't have a little 2. And then the square root of 100 we talked about is 10, or it could also be negative 10. But this left side still was only x minus 3. Just dropped its exponent again. Now, do you think I'm done with this problem? No, because I don't have x alone yet. So what should I do to get x alone? Add 3. So I get x equals 13. Does that mean my other one will be negative 13? No. Don't fall into that trap. It's not always going to end up being the same thing both times. So the other one's going to be x equals negative 7. Notice that these answers are starting to look a little bit similar to what we were doing on the last section where we had to solve. Remember, we had to set it equal to 0, factor it, and set up two equations. Here we have two equations and we solved them. So these are using some of the same ideas that we've already talked about. All right, on number 6. First thing I need to do. Square root. We need to get rid of this little exponent. So to get rid of it, we square root. But if you do it to one side, you have to do it to the other. Kian? Okay. Jakeem? Okay. Good. But also? Good. So when we square root the left side, we get x plus 4, just without an exponent now. The square root of 36 could be 6, or it could be a negative 6. And then we have to solve both of those. We would solve them by doing what? Subtracting 4. So x equals 2, or on the other one, x equals negative 10. Good. Got 2 answers again. Questions before we move on? Okay. 7 and 8 get a little bit trickier. What's different about them? There's a number in front of our parentheses that gets squared. So kind of like we had to do on, which problems were they? 3 and 4, I think. We need to undo the multiplication first. Now, I want to warn you, you cannot distribute this 7 because of that exponent. So distributing is not an option here. You cannot do it. So how are we going to undo multiplication? Divide both sides by 7. That has to be our first step. We've got to get rid of that 7 first. Before we can square root, whatever is getting squared, whether it's a set of parentheses, a variable, whatever it is, it can't have anything else around it in order for us to square root it. So we have to get rid of that 7. So we are left with x plus 8, still in parentheses, squared, is equal to what? Negative 4. Next thing I should do, square root. Now that the squared part is all by itself, we can square root both sides. So when we do that, if we square root x plus 8 squared, what do we get? X plus 8. Can I square root negative 4?
Yes.
Try doing it in a calculator. What's it going to say? It's not going to work. It's going to come up with an error because we cannot square root a negative number. Part of the reason for that is you cannot take a number times itself and come up with a negative. If you're taking 2 numbers multiplied together to get a negative, one of those numbers has to be negative and the other one has to be positive, which means they can't be the same number if they have 2 different signs. So I would just erase that because it's not going to work. What are we going to put as our answer? If we can't do it. What? We cannot do it. This is impossible. Doesn't work. There's no real solution. Now, if at this point you you forget to put the word real in there and you put no solution, I would be okay with it. Technically, there is a solution. It's just imaginary or complex. So it's something we haven't learned yet. So if you're trying to square root a negative number, there is no real solution. Questions, concerns? Okay, so then we go to number 8. Is this one going to be no real solution? We don't know yet. So, let's see, what should we do first? All right, we should divide by -2. We need to get the squared piece alone before we can square root. So x minus 3, still in parentheses, squared, is equal to what? Positive or negative? Positive 81, because we took a negative divided by a negative. So do not try to make the determination about no real solution until you're ready to square root, because sometimes your negatives go away. Now we are ready to square root. You got to get rid of that squared. So what do we end up with? X minus 3 equals 9, or? Good. Last thing I need to do to solve these. Add 3 on both sides, so x equals 12. Or x equals -6. Good. Questions, concerns? All right. Number 9, we're switching it up again. How is number 9 different from the last couple that we did? No parentheses. So what are we trying to get alone before we square root? The x squared. Okay, so we need x squared to be alone before we can square root. What do you think we need to do first? Add 3. So go back to your how you would solve an equation. If the squared wasn't there at all, I think most of you would know to add 3 first. We add 3 first, so we get 4x squared equals 160. After that, we would have to... No, are we ready to square root yet? We have to divide. We can't square root until the x squared part is all alone. So x squared equals 40. Now we're ready to square root. Is 40 a perfect square number? No, it is not, which means we have to make a factor tree. What will 40 factor into? 2 and 20. 20 factors into what? 2 and 10. 10 factors into 2 and 5. We have a pair of 2's. What's lonely? 2 and a 5. So when we do this, we would get x is equal to what? 2 on the outside of our radical, 10 on the inside of our radical. But how many answers are we supposed to get? 2. So what's my other one? Good. So if positive 2 root 10 is a solution, negative 2 root 10 is also a solution. Questions, concerns on this one? Big idea is make sure the squared part is alone before you try to do anything else. So to get the squared part alone on number 10, what's my first step? Subtract 10. 2x squared equals 200. Then I should divide by 2. X squared equals 100. Last step. Square root is 100 a perfect square number? Yes, it is. That makes my life easy. So I know my answers are 10 and negative 10. Good. We went through that one pretty quick. Do we have questions about it? Okay. Moving right along. Now we're throwing kind of all the ideas together. What needs to be alone before we square root? The parentheses need to be alone. So the parentheses are what's getting squared. The parentheses are what has the exponent. So those parentheses need to be alone before we can square root. So what should we do to get the parentheses alone? What do we do first? Okay. So one step at a time. Add 4. So we have 6 times x plus 9 squared equals 36. Then we can divide both sides by 6. So x plus 9 squared equals 6. Now what are we ready to do? Square root. So I'm going to jump up. Nah, I've got room down here. So we get x plus 9 equals, can we simplify the square root of 6? No. So what's it going to be? No. If you can't simplify it, it just stays the same. It's the square root of 6. Or we could have x plus 9 equals negative 6. Negative square root of 6. So to solve the one, well, either of them, to solve them, what do we have to do to get x alone? Subtract 9. When we do that, square root of 6 and a negative 9, are those like terms? No. So what that means for our answer is we would have negative 9 plus square root of 6. Now, if you put square root of 6 minus 9, that's the same thing, as long as the square root is only on top of the 6. For our other one, when we do it, x would equal negative 9 minus the square root of 6. And those would be our two solutions. Even though they're not pretty, that's how we would have to do it. They're not like terms, so we've got to just leave it alone.